Hello, welcome and good evening. And today I've got a new little toy, and I was as surprised as most people that it would come out at this point of year, and it's the Raspberry Pi 4. I've already had a couple of projects with the Raspberry Pi, most notably with the Pi Zero because it's the smallest and I didn't need any display capabilities or something. But I also have a bunch of older Raspberry Pis, namely the very original version that's still serving as an Apple AirPlay outlet, so I can stream stuff to my hi-fi equipment, so I can listen to music and stuff. And for that it's really still a good thing. But it's actually a very low-end device with, I think, 600 megahertz single core and only 256 megabytes of RAM. But yeah, it's now 7 or 8 years old. It's from 2011 or 2012, so it really worked hard and it's still going strong, so I don't complain. It's really a very nice little computer still and can do still lots of things. Then of course the Pi Zero here, which is also single core but has a lot more RAM, and it's just nifty little small device. And I also have two Raspberry Pi Model 2, which serve different purposes. One is just for tinkering, the other is running, I don't know, some Plex media services for all the DVDs that I don't want to put in the drive, but I just simply buy a DVD, rip it to the Plex media server, and then I can just watch it via the Apple TV, which is convenient. And for that the Pi Model 2 is totally sufficient to run the Plex server software. That's pretty nice. And yeah, I skipped the 3 because I didn't have really a need for it. But now the 4 has come out and it is a significant upgrade. For instance, you can buy it with 1, 2 or 4 gigabytes of RAM. Most people probably want to have either the 1 or the 4 gigabyte version. I took the 2 gigabyte because it was available. The 1 gigabyte was already sold out. And I think the 1 gigabyte starts off at at 35 pounds. In euros it's, I don't know, 40 euros maybe? I'm not sure what the exchange rate currently is. Or maybe also around about 35-ish to 40 euros. And 2 gigabytes and 4 gigabytes cost a few euros or pound more. And the 4 gigabyte will enable you supposedly to really run it as a desktop computer, which makes sense, and we will take a look how this works with Chromium or Chrome or whatever is available as a browser, for example. And we'll run 1 or 2 games on it because the video core unit has been upgraded slightly. I mean, it's still not a great 3D graphics accelerator, but useful for a couple of games and stuff, and it can do hardware H.264 and H.265 decoding and also encoding as far as I know. Yeah, and it's pretty neat. Let's have a look. Actually, I haven't opened it yet. So there's a lot of places where you can buy this. Some places are already sold out because it's proving to be really popular. Oh, look at this. Here's a little instruction manual, saved in user guide, and some very basic things you should read. This is probably the instruction manual. It looks a bit weird, doesn't it? I think this is supposed to be the instruction manual, and you should look at it, probably read it even. And you should handle the Pi only at its edges, which is fair enough, I would say. You should watch the temperature. Not sure what this here means, the baggy thing. You shouldn't touch any of the pins here because of when it's connected to power, because you probably can short out the GPIO pins if you have got like wet fingers or something. And what's this? I don't actually know. What is this supposed to mean? There's something here? No idea. But if you have questions, you can go to raspberrypi.org. Yeah, okay. We do know that. So let's have a first look at this thing, right? So what springs to my eye is already this here is the CPU with sort of like a metal thing on top for cooling probably and protecting the die. I think the Model 3 had that already, but I never had that one. And it says here Broadcom, so it's still the same supplier, of course. This is probably the DRAM, the 2 gigabytes. Here are 2 ICs, which are probably the USB interface and the Ethernet. Ethernet is now not a USB device, so you get full speed gigabit in Ethernet, which is very nice. So this makes it viable for an NAS or media server, whatever, even better than before. There's also a power over Ethernet plug here, so you can use it as really as a server in a rack and stuff, and you only need to provide power and Ethernet over this thing here. Very nice. Display and camera connector. This is for high-speed display. You can also do SPI displays via this, but they are slow. So this is the high-speed TFT interface, and this is the camera interface, the same that I'm using on the Pi Zero. It also has got 2 mini HDMI outputs with 4K capabilities, so you can really use it as a dual screen desktop environment. USB-C power input. This is probably all the power supply stuff here. An inductor, some capacitors, and some kind of chip here, which is, I don't know, we could look it up. And the reset stuff got moved from here to here. On the Pi Zero it's still here. As you can see here on the Pi Zero, there's this run header, which allows you to reset the whole thing from a head or something that you put on top of it. Alright, so there's still the headphone jack, which also outputs composite video, so you can still attach it to old TVs and stuff, which is nice for RetroPie projects and similar things. I don't have a case yet for this, but I will order one in time. For now it's not that important. This is probably the Wi-Fi module with a shielding here, and I'm wondering if there is any antenna visible. Not really. There's a micro SD slot, which reminds me we need to find a micro SD card. Shouldn't be too hard. But other than that, I actually don't see an antenna here. I wonder how they do it. Usually they have like this small omni-antenna thing, which is like on the ESP here. This is the antenna basically printed onto the circuit board, and this gives us a pretty decent range and reception and transmission capabilities. But I can't spot it. Not sure where they hid that or how they do it on this board. Maybe below the sticker. Maybe this one here, this tiny, but this could also be resistance or capacitance or something. I don't know. Yeah, fair enough. Oh, there are the holes for the ball grid area of this chip here. Or is it? No, it has actually on the sides. It's probably just vias. Not sure. No, it's not even vias. It's all connected to the ground plane. Not sure. Some test points. If you've got something broken. A lot of test points actually. That's neat. Yeah, USB 3.0 capabilities, which is also nice, and 2.0. Yeah, a lot of stuff on here. It's become really a powerful, neat little computer. And since I don't have any USB-C power supplies because I only have like old Apple devices and stuff. I ordered this as well. This is like €1 extra to get a converter from micro USB to USB-C, and this should be fine. So I'll just pick up a 5-volt power supply and we're ready to go. I'm gonna, and also noteworthy is the micro HDMI. So you need to pick up one of these cables, which is micro HDMI on one end and HDMI on the other end. So I'll hook this up and we will prepare a Raspbian image on an SD card for this and then boot this thing. Alright, so you can download the Raspbian software from raspbian.org, and we basically go here to images and let's see, produce and release blah blah blah, images for Raspberry Pi. Unofficial, no, we want official. The Raspberry Pi is produced and released. Raspberry Pi website downloads page. So yeah, here we are. And you can either use the Noobs or the Raspbian distribution. I usually use Raspbian because it's closest to standard Debian. And yeah, I'm just used to that. And we download a zip file. And here's here also the main page for the Raspberry Pi. And yeah, they now really market it as a desktop computer. And it's really, I think the Raspberry Pi is really a good idea because it gives everyone the ability to tinker around, learn programming and stuff. And yeah, I think like you should give one to your kids if possible to make them more computer literate, basically. And that's actually a very nice thing. So let's skip ahead in the video until the download finishes and we can write it to disk, to the SD card. So the download has finished, and as usual we use the Etcher tool to write the image to the SD card. It's a simple process, just select the Raspbian image, then select the target drive, which shouldn't be one of your hard disks, but the generic storage device. And just click continue and flash. And it will ask you for root permissions, which is fine, especially since you will delete everything that was on that disk. And it will take a few minutes, 5 minutes on this device roughly. So yeah, I won't let you sit through that one. We'll also fast forward, of course. And there it is. So it seems it was successful. It even does the validation, which is quite nice. We can flash another. We rather not, I would say. What is interesting is that the device doesn't show up right now. Usually you see the boot partition. I'm just going to unplug and replug the SD card. And indeed, here it is. So it seems that it was successful. There's all the kernel images and everything, bootloaders, and it looks excellent. So we'll just disconnect that and continue booting the Pi. When booting up the Raspberry Pi, you're always greeted by this rainbow-colored patch and the 4 Raspberry Pis, which signify the 4 cores of the system. And with the new Raspbian, it will also resize the root file system automatically, and then reboot again, show the Pis again, and then you might see a flash of boot messages or not. It takes a couple of seconds for the systems to start up, and my capture device doesn't get all the graphics here. I probably have to tweak that. We'll do that in a minute. But the system will be up and running in about a minute. So we are roughly 50 seconds into the first boot now. Didn't have to press any keys yet. It's all automatically done so far, and we, after exactly 1 minute, are on the Raspberry Pi desktop. And you're greeted with a little welcome screen, and it will ask you about a couple of things that you can set up to make the Pi join your home network and language settings, etc. First of all, we set our country and the language. I will pick German here because I'm in Germany, so the time is correct, and I will choose English language and US keyboard because that's what I got attached to the Pi right now, and it will take a few seconds to set everything up, and the time will be correct, etc. And then you have to set a password for the Pi user, which is also nice so that not everyone can hack your Pi. After that, it will automatically search for Wi-Fi networks, and that takes a couple of seconds. I'm going to choose my home network here, and the next step will simply ask you for the passphrase of your Wi-Fi. Just type it in, hit next, and you should be good to go. Afterwards, the Raspberry Pi will ask you to restart the system to apply all the settings, and we will just do that really quickly now because the next boot is actually much faster. It takes only a couple of seconds to go to the splash screen and then to boot into the desktop in a couple of seconds. I've cut this a few seconds short, but in real life it's not that much slower. There's a bunch of programming environments shipped by default, a few Java environments, Scratch programming language, the SenseHead emulator, Sonic Pi for making synthesizer sounds and electronic music, and the Python IDE. You can try out all of these, and there's a lot of documentation for that as well. But for now, we'll skip that and maybe take a look at the web browsing capabilities, because this was something that the Pi was actually not very good at all. And what better way to test the web browsing capabilities than by going to YouTube, actually. And of course, we'll check out one of my own videos and see if it plays at all or well. The performance here already seems, well, quite usable, not as fast as on maybe a current desktop machine or something, but it's not unusably slow. So let's open the SnarkMarker video, and yeah, it looks like the video plays. I didn't record any sound with this, so you'll have to excuse that. But the video playback seems fine. It's not at all jittery or anything, it's completely fluid. So probably also using the hardware decoding that is on the Broadcom chip, which is actually a pretty nice thing. So the Broadcom chip supports H.264 and H.265 in hardware, which is a very useful thing indeed. But you can also use the Raspberry Pi for your own Office-style applications. LibreOffice is pre-installed. You can open up Writer and create some letter or document or your homework, whatever you like. And it's reasonably fast. It doesn't feel any much slower than on any other modern PC or mobile device. Of course, this is not really testing the limits of the hardware. That would probably go to some of the games out there, and this is definitely not a gaming machine, naturally. Performance of the video core chip will be much slower than even the lowest graphics card that you can buy nowadays. But let's try out one of the games that's pre-installed, and that's Minecraft Pi Edition. And this is a special version of Minecraft which I have to admit I have never played in my life, so let's just simply start this thing and create a new world. It takes only a couple of seconds, and as you can see, it actually works quite well. You can run around, do stuff, but I have really no idea how to do any of the stuff here. I realized that I can jump, but other than that, I can only say it looks fine, it plays fine. Yeah, that's probably something the kids will like. The good thing about the Pi is that it uses RasPi and you can install so much software that's in the Debian repositories. For example, SuperTux card here, which is a bit more taxing probably 3D-wise than some of the simpler games. And also this works fine, so the 3D acceleration works. Note that you have to enable this in the RasPi config program, which I haven't shown yet. But this is something that you can read up in the documentation. And yeah, I have to say, this is really a fun little machine. You can run ScumVM or other retro emulators on there as well, which is no big deal. Play maybe Quake 3 Arena or some other older games. Newer stuff, of course, will not run. Also, the ARM platform means that you need programs specially compiled for this. Stuff like Steam won't be available naturally, at least not yet. Who knows what the future brings, but the processing power is, of course, only comparable to handheld devices like smartphones, etc. However, talking about performance, we can also have a look at some browser benchmarks. Notably, I've run the MotionMark suite here, and this takes, I don't know, maybe 15 to 20 minutes or something to run to completion. And yeah, the Chromium browser does it very well. I've sped things up by quite a lot of percentage. And in a couple of seconds we will see the end result, and the Pi here scores roughly 5.78 on the MotionMark, with a pretty high inaccuracy of 35%. And when we compare this to the iMac, we will see that my 2013 iMac scored roughly 390 points. So this is not even a competition. This is so much better and faster that you see the Pi has improved by quite a lot compared to the older models, but still, from raw benchmarks, it can't replace a desktop computer. But that's probably not what you need or want. You can still do a lot of productive things with the Pi, and yeah, it doesn't matter how fast your browser currently gets, because you can do only so much as a human being. So if you don't have any too much taxing graphical work or so, the Pi will be fine. Okay, so here we have all the 4 different Pi models that I own. This here is the original Raspberry Pi 1 Model B. There was also Model A, which didn't have the Ethernet connector, and also I think it had less RAM. So the CPU and the video core chip are beneath this black DRAM chip here, which is 256 megabytes. This whole thing I think, runs at 600 megahertz or something, as I said. You've got the HDMI out, but also a big RCA jack for composite out. Audio comes out here, but as usual there's no DAC, but it's being done by pulse width modulation, so the quality varies. It's not very good, actually. 2 USB 2.0 ports and the Ethernet jack, which is also a USB device, which is why you don't get the full 100 megabits. The GPIO ports on the Raspberry Pi 1 are much fewer, and they are also incompatible with the later GPIO pins. From the 2 onwards, they are much more numerous and they are all compatible from the 2 to the 0 and the 4, and of course the 3, which I don't own. But other than that, this whole thing here, on the back you have the big SD card connector, and that was switched to microSD on the Model 2 and the 0. The Model 2 is already, I think 4-core, 2 cores at least, I'm not sure, is it 2 cores or 4 cores, but much faster. I put a heatsink on there. The DRAM went to the bottom of the PCB, they changed that again with the 4, maybe also the 3. And you've got 4 USB 2.0 ports and the 100 megabit Ethernet jack, still connected via USB as well, so you don't get full speed. The camera and display connectors are all the same, so that's electrically compatible. The 0 doesn't have the display connector, only the camera connector, and a mini HDMI port for connecting a display. And as you can see, the 0 is much smaller. It has only 1 core, so lower power, and half a gigabyte of RAM. And it's only slightly longer than the other Pis are wide. So the basic footprint is always the same, but as you can see, the holes for mounting are slightly different. And of course, the cutouts in the case need to be slightly different. Ethernet jack went from this side to the left side, etc. But this is an actually very nice evolution that you can see here from the oldest Pi to the newest. And they were able to pack so much more in. So the Raspberry Pi 4 has written on here copyright 2018. So it has been, it seems, quite a few months in the making. And the Raspberry Pi 1 on the other hand says copyright 2011. So there's something like 7 years or 8 years. I'm pretty sure I bought this in 2011, like 8 years difference between the first and the last model. And yeah, we got much more power. If you take a look at the benchmarks online, it's even not comparable. It's like night and day. And of course, the 2 gigabytes of RAM or the 4 gigabytes in the top model make it so much better. Okay. Yeah, I think this is about it, what I wanted to tell you. Definitely a very interesting, nice little piece, and it has gotten so much better compared to the Model 2 and the Model 3. This is one of the best platforms, I think, for anything that you want to do, be it desktop computing on a budget, basically, or doing retro stuff, emulation, watching videos, browsing the web, learning how to code, tinkering with the GPIO. It's really an amazing little device, and the dual screen makes it even better, of course. Haven't shown you that here, also I only have one cable right now, but maybe in the future. Only downside is it's getting pretty hot actually. I mean, it's probably all in spec, but I will probably also put some cooler on here as well, because when it runs at full 100% CPU, I really can't touch the surface without burning my fingers. I think that's at least 80 degrees or something. Yeah. Alright, that is it. I wish you a very nice evening. If you like this video, please click the like button. Definitely share this video with your friends, and most important of all, subscribe and help me get to the next milestone. Have a nice evening.